Hi, this is Mrs. Sharada. I'm going to be reviewing some of the exponent rules that may be confusing you. Please pardon the quality of this video as I'm trying to record and write at the same time. So when you look at an exponent, it has two parts, the base and the actual exponent or the power. Now, the important thing to remember is that you can only combine terms that have the same base. So you may be asked to multiply two numbers that have the same base. If you have 5 to the third power, what that really means is 5 times 5 times 5. And then 5 to the second power really means 5 times 5. So if you have to multiply 5 to the third power times 5 to the second power, you'll see that you end up with 1, 2, 3, 4, 5. You have 5 to the fifth power. So the rule when each exponent has its own base is that you keep the base, and add the exponent. Now, you may also be asked to divide numbers that have the same base and an exponent. So when you were to divide this number, 4 to the 7th power means 4 times itself 7 times, 1, 2, 3, 4, 5, 6, 7, and divided by 4 to the 5th power, which means we have 4 multiplied by itself 5 times. Now if I wanted to simplify that, I could cross off a 4 on the top and the 4 on the bottom and simplify them to ones. And I'm going to keep doing that until I get rid of as many 4s as I can. And so on the bottom, 1 times 1 times 1 times 1 is just 1. And then 4 times 4, I still have 4 to the second power, or 16. So the rule when you divide numbers that have the same base and different exponents is that you keep the base and subtract the exponent. Now, another thing you may see is something that's the power of 0. Now, I'm going to go ahead and write the rule first. And the rule is anything to the 0 power equals 1. So if I have the number 9 to the 0 power, it equals 1. If I have the number 6 to the 0 power, it equals 1. Anything to the 0 power is 1. And the reason that is true is because over here, if I write out this problem, 2 to the 4th power divided by 2 to the 4th power, and I simplify like I did before, 1 times 1 times 1 times 1 is 1, and 1 times 1 times 1 times 1 is 1, which is 1. And if you had followed the rule from up here that you subtract the exponents, we would have had 2 to the 4 minus 4, and we know that 4 minus 4 is 0, so we would have had 2 to the 0 power, which is 1. So these are some of the rules. So let's move forward and let's talk about a couple of other things that you're going to encounter in these lessons. You may see some numbers where you notice that there is only one base and there are two exponents. Well, to help understand the rule for this, I'm going to go ahead and I'm going to write this in expanded form. What this means is we would have 4 to the 2nd power 3 times. So this would be equal to 4 to the 2nd power times 4 to the 2nd power times 4 to the 2nd power. Now before we said if they each have their own base, you keep the base and you add the exponent. 2 plus 2 plus 2 is 6. Now, the rule, if you look at just these and you wanted to know the rule without writing it out, the rule is going to be that if there's only one base and the other exponent does not have its own base, you keep the base and multiply the exponent. Now, it's important that you notice that there's only one base, because remember, the problem 4 to the second power times 4 to the third power is a completely different problem. Back then, we would have added the base, but these ones don't have their own bases, so we are going to keep the base and multiply the exponents. Well, sometimes when we're asked to solve a problem, you're going to notice that your answer comes out with a negative exponent. Because remember, the rule from before tells me that if they have the same base and it's division, that we are going to keep the base and subtract the exponents. You always have to do them in the order they're there. So we have 3 minus 5. And that would be 6 to the negative second power. Now I'm going to write this out the long way so that you can see what would happen. So I'm going to have 6 times 6 times 6 on top, and 6 times 6 times 6 times 6 times 6 on the bottom. And if I simplify, here I have 1 and 6 to the second power. Now those look different, but actually a negative exponent means you have a very small number. And so if you notice, fractions make very small numbers. So 1 over 6 to the second power would be 6 times 6, which is 36. So we would have 1/36. Now, when you see negative exponents, you're going to have to change that into a positive exponent. So the rule is if you think about this like it was a fraction, we know to turn that into a fraction, you put a 1 under it. But if there's a negative exponent in the numerator, you're going to push it to the denominator and make it positive. But if it was in the denominator, you're going to push it to the numerator and make it positive, because in our final answers, we don't want any negative numbers. To help you understand that a little bit better, I'm going to show you how to simplify these problems here. So I want to get rid of this negative second power. It's in the numerator, so I'm going to move it to the denominator, and I'm going to make it positive. So now it's 3 to the second power. This is already positive, so I'm going to leave it down where it was. I'm going to put a 1 on top, and 3 to the second power times 3 to the fourth power is 3 to the sixth power. Now if you had done that the other way where you just subtracted, you would have had 3 to the negative second divided by 3 to the fourth, and you would have had 3 minus to the negative second minus 4, which is also 3 to the negative sixth, which you would have turned into 3 to the 1 over 3 to the sixth power. I apologize. So I just like to think of it in a more simplified way. Instead of writing it out this long way, I like to just think that if it's in the numerator, I'm going to push it to the denominator. And in this example, it's in the denominator, I'm going to push it to the numerator. I am just doing the inverse. And so on this example, I end up with 4 to the seventh power. Because this was negative, so I had to push it to the numerator. This was already positive, so I left it alone. Here I have 2 negative exponents. So to make them positive, I'm going to take the 1 from the numerator and put it in the denominator. And here I'm going to take the 1 from the denominator and I'm going to put it in the numerator. And if I had 3 5s on top and I had 4 5s on the bottom, and I were to simplify it, I would have 1 5 left on the bottom. So when you talk about exponents, you want to get rid of negative exponents by moving them in the fraction. And so I explained why up top, but the easier way to simplify the rule is if it's in the numerator, push it to the denominator. If it's in the denominator,